This is the CAPS DBE NSC November 22, paper 1. Question 7 is the calculus polynomials section. Determine f dash of x from first principles if f of x is equal to x squared plus x. So we know if we check this using the power rule that our f dash of x is going to be 2x plus 1. So we can use this just as a reference. So this is not for marks. This just, we can use that as a reference. If we don't get that as the answer, then something's gone wrong. Right, first principles, easy marks, very formulaic. F dash of x is equal to f of x plus h minus our original f of x all over h. So the goal is to get these into our position, and we want to take h out as a common factor on the numerator so that we can cancel h out of the denominator, because we can't have h being 0. So therefore, that's the full goal here. So let's start. F dash of x. Excuse me, I forgot my limb. My limb. Solve that problem. Don't forget your limb. Our limit is as h tends towards 0. Okay. We don't have to write f dash of x each time. Let's just use one equal sign. So lim as h tends towards 0, f of x plus h, wherever we saw an x, we just switch it up for x plus h. So x plus h squared. And then we had a plus x, so plus x plus h. That's all minus, you can keep this in a bracket because the negative is going to affect it. It'll be minus x squared plus x if you do it in this way. All over h has not gone away yet. Right, so this next step, let's get this all times out. Don't forget your lim. Don't forget your lim. Times out x plus h squared, we get x squared plus there's 2 of those, so 2xh's plus h squared. This just stays the same. Plus x plus h minus x squared minus x all over h. But we can't take out the h as a common factor yet, but there's lots of cancellations that should happen. So the x squared terms cancel out and the x terms cancel out. Now we have our h as a common factor. Don't forget your lim. H tends towards 0. Take out this h as a common factor, an h in each term. So take out h as a common factor. Here if we divide this by h, we're left with 2x. If we divide this by h, we're left with h. And if we divide h by h, you're left with 1. All over h. Finally, our h in the denominator has been cancelled out. So in the next step, we can finally drop the lim. So h is 0. I'll just do an extra step here for purposes of seeing what I did. You don't have to write this step. We subbed h as 0 here. So just to know what we did. And that's equal to 2x plus 1, which if we go back and check, this was our correct answer. Number 7.2, now we can use our power rule. So the power rule states that if f of x is some sort of a value, x to the power of n, then our first derivative, our f dash of x, will be that original n times by the a value, and then you minus 1 from the n value. Okay. So in practice, it's 5 times 2 is 10. 5 minus 1 is 4. And 4 times minus 3 is 12. And 4 minus 1 is 3. And this is, the 8 is x to the power of 1 minus 1. So it's 8 times 1 is 8. x1 minus 1 is x to the power of 0, which is just 1. So you don't write that down. X to the power of 0 is just equal to 1. Number 7.3, the tangent to g of x, so this is the ABCD thing, so there's three unknowns here, has a minimum gradient at the point of -1, -7. For which values of x will g be concave up? So this sort of question, got a lot going on here. So the tangent to g has a minimum gradient. So we're not looking for the minimum grade, the min and max. We're not looking for min max of g. We are looking for min max of actually the tangent, which is the g dash of x is going to be the tangent gradient. So what do we know? We look at this question here. We know that for minimum and maximum, we do f dash of x is equal to 0. So the first derivative equal to 0 will give us the x's of our minimum and maximum point. But we're not doing this, so it's not this. It's not this. What we actually want is the min-max of the first derivative. So the min-max of the first derivative is going to be where f dash dash of x is equal to 0. Okay, this is how I'm understanding this question. We want where the second derivative is equal to 0. So this is what we're gonna look at going forward. So first we need our first and second derivative. So to use the power rule, g of x is equal to a x3 3 x squared plus bx plus c. We want concave up and come back to that. Okay, first derivative. So it's 3 times a x2, 3 times 2, 6x plus b, and the c falls away. That's our first derivative. But we're not using this, so we're going to go ahead and do our second derivative. So we take 2 times 3 is 6a, x 2 minus 1 is just x plus 6 times 1 is 6, x 1 minus 1 is 0, so 6ax plus 6. That's our second derivative. So for g dash dash of x, our second derivative, if we want min max, we equate it to 0. Equal to 0. And we want to solve for, we've got too many unknowns here. I'm going to go back to the original question. We have an a and an x. So let's take a look. There's a minimum gradient at point, we can borrow this x value because we know that it's going to have that x value at the minimum. It will have the x value minus 1. So we can sub x equals to minus 1. So 6a minus 1 plus 6 equals to 0. Now we can get our a value. We take 6 over the equals. Oh, that's a 0. Minus 6 equals to minus 6a times minus 1 by 6. Divide both sides by minus 6, and we get that a is minus 6 over minus 6, which is just 1. Our a is 1. We can sub this a value into our f dash dash of x. So our second derivative, we can now sub in this. Oh, it was a g. Okay. G dash dash of x is equal to 6 times minus 1. Oh, just 1. 6 times 1 x plus 6. So it's just 6x plus 6. So the second derivative is this. I'll go back to the question. It asked for, so we've used this information and we've used this information, we've used this information. Now it wants what x values will g be concave up. So for concave up, we know that our second derivative for concave up, oh, let me just create a little bit of space. Okay. So we know that for concave up, our second derivative test is the second derivative must be positive. Second derivative is positive for concave up. So we can say g dash dash of x needs to be larger than 0. It needs to be positive for concave up, and that will give us the x values that we have been asked for. So g dash dash of x was 6x plus 6 larger than 0 minus 6 over 6x. So x has to be larger than minus 1 for the concave up. Quick note on the concave up, concave down. Just if you remember, the concave up is this direction, and this would give you a local min at the bottom, the amount at the bottom, and for concave down is this direction. And so this is your local min. Just for interest's sake, this would be a local max. Concave up, concave down. And the second derivative test, we needed concave up is where our second derivative is positive. And I just remember it's positive as the smiley face one. Oh, that concludes, this was question 7.